The key to this question is realizing that if you have an atom, then the number of protons and the number of electrons have to be the same. So protons, same protons and electrons. Because an atom has no overall charge. A proton is positively charged and an electron is negatively charged. So the easy way to work out how many protons and electrons you should have is to use the atomic number, or Z, okay? So Z is the atomic number or proton number, and that tells you how many protons you have in the nucleus. So if you have the number of protons, then you will by default know the number of electrons in an atom, okay? Now, it's worth making a point that the identity of an element is based on its proton number or atomic number. So for Z equals 25, for example, that is always manganese, okay? If Z was 26, it would be iron, right? So the number of protons in the nucleus and the identity of the element are intrinsically linked. That is literally how we identify elements, okay? If we have an iron, it has gained or lost electrons, so it will now have a charge. The net charge is going to depend on whether you now have more or less electrons than you do proton. Okay, so an ion is a charged species formed from gaining or losing atoms. Okay, two flavors of ions. Okay, gains, loses electrons, so it's charged. Right, so an anion has an overall negative charge. Well, if it's got a negative charge, does it have more electrons than protons or more protons than electrons? It's got to have more electrons than protons, so there is a net negative charge. So that happens because it has gained one or more electrons. So that's how anions are formed, okay? A cation has an overall positive charge. So how would you end up with an overall positive charge? Well, you must now have more protons than electrons, so it must have lost electrons. So there now is excess of positive charge compared to negative charge. An easy way to remember which one is which is anion is negative. So that's how I remember that one. And a cation, if I write the T as a big plus in the middle, cation is plus is positive, right? So that's how I teach people to remember that. So a key to answering this kind of question is look at the number of protons and number of electrons and work out if there is a net overall charge. And that will tell you if you have a cation, an anion, or a neutral atom. If you've only been given the number of protons, help, I don't know what element we're talking about. Well, the number of protons tells you the element. And of course, I picked this periodic table because it said it was the ACS one, and I thought that would be a good thing, but the numbers are absolutely teeny tiny. So we're going to try and answer this anyway, regardless. I'm going to squint like the old person I am. So first line, we have been told with a neutral atom, so the number of protons and electrons must be the same. So how many protons have we got? 53. That tells me the identity of my element. So I'm going to squint real hard and look at the Z, and I think that iodine has a Z of 53, if I can read that correctly. So the identity of the element is iodine. So we can fill out, because it's a neutral atom, the number of electrons is going to be 53, because I'm expecting 0 net charge, right? So plus 53 minus 53 equals 0. I now know that that element is iodine, so there'll be no charge associated with that symbol. All right, line 2, magnesium 2 plus, okay? So because that one has a positive charge associated with it right here, that's telling me it's a cation. It must have lost electrons. How many? Oh, I don't know, panic. But I've been told it's magnesium, so that means I'm going to be able to find out how many protons it has. So first of all, let's make sure we check the cation box before we get carried away. So magnesium then, where are you, magnesium? Here it is, and it has Z equals 12, if I can read that, okay? So now I know that magnesium has 12 protons. However, this is a magnesium 2 plus cation. Note that when we write the symbol for a cation, we write the number before the charge, like magnesium 2+, strontium 2+, cobalt 2+, for example. But when we talk about the charge of it, we say it's +2. Just like we would do mathematically, okay? So I don't know why the convention is that when you write an ion charge that you put the number before the symbol of if it's positive or negative, but that is how we roll. So we're going to stick with that convention. Okay, so magnesium 2+, it therefore must have a net charge of +2. So you've got 12 +1 charges from the protons, and then we don't know how many electrons there are, but the net charge has to be +2. Therefore, there can only be 10 electrons, okay? So do the math. 12 minus 10 gives you 2, okay? So we can be happy that we've worked out the number of electrons correctly. You can use a little algebra if you find that tricky, that's okay. All right, so then the last row, we've only been given the number of protons and the number of electrons. So the first thing I'm going to do is identify which element has 8 protons. So I'm going to go back to my periodic table and look for an atomic number Z of 8, and that is our dear friend oxygen. Okay, so now I've identified the element we're talking about. Now we have 10 electrons, so that means we've got an excess of 2 electrons compared to the number of protons. So if I was going to work out my net charge, +8 minus 10 gives me, drum roll please, a net charge of -2. So -2 means that is an anion, because anion has negative charge. So if I was going to write my symbol, it's going to be oxygen and then superscript. I'll just do this for superscript 2-. So note that the number comes before the charge. That is the convention. So that is a O2- anion. Okay, let's do another one because these are fun. All right, you'll do. Let's get rid of all this gubbins here. Okay, probably got some stuff over here too somewhere. Okay, so our first row, we've been told the symbol is F-, okay? It's got a minus charge, so it must be an anion, because anion is negative. Which element is it? It is fluorine. Fluorine is over here in the periodic table. It has Z of 9, so the atomic number is 9. That means it has 9 protons. If fluorine has 9 protons, it's got a -1 charge overall. It must have 1 additional electron. So we have a net charge of -1. So it must have 9 plus 1 would be 10 electrons. So just make sure we end up with the right net charge. +9 minus 10 gives me an overall net charge of -1, which matches the symbol on that anion. All right, row 2 then, a mystery species, but we know it has 51 protons in the nucleus, which means it has atomic number Z of 51, which is going to be, is it, yeah, I can't read. Is it 10 or antimony? 51? I'm just trying to read the numbers here. 49, 50. It looks to me like it. Oh, there's a typo in this. ACS. No, it should be antimony, right? Because the periodic table is arranged in order of ascending atomic number. So do I have a periodic table around here that I can just check that that is indeed the typo that I think it is? Because funnily enough, I haven't entirely memorized the whole thing. Periodic table. I've got one on the wall behind me. I could turn around. Yes, antimony. SB is 51. That definitely looks like a 2 to me. Naughty, naughty. Okay, so our element is going to be antimony, which has the symbol SB, stibium. It comes from the Latin, right? We have the same number of electrons, so our net charge is 0. So that is telling me it is an antimony atom. So I'm just going to write SB with no charge associated with it, and I'm going to check that neutral atom box. All right, and then line 3, what have we got here? So our number of protons is 25. That's our friend manganese right here. But there's only 22 electrons, so our net charge is going to be +25 minus 22. We're going to end up with a net charge of +3, right? So that means we have more protons compared to electrons. We've lost 3 electrons. So we're going to have a cation because that's a net positive charge with a +3 charge. So that will be manganese and then superscript, which I'll do this for, +3 for the manganese +3 cation. All right, Have fun with those.